So this time we're going to dive into this notion of polymorphism. Polymorphism is what takes objects from just kind of sharing some interesting stuff into behaving interesting ways. If you take the word polymorphism, many, morph is form. And so the idea is an object can have many forms that it's going to take as it goes through that. And so within polymorphism, what we're trying to get to is flexible behavior of our objects. We've seen this a little bit already, whether you realized it or not. We're kind of coming back to that because that toString we talked about is actually acting this way. So I want to have some object that says do a thing. I want to print a thing. I want to pay for something. I want to communicate with somebody else. I'm not worried about how it's done specifically. I just want it to be done. There's actually many flexible solutions by which it can be done. I just want you to meet a contract. That's the idea behind polymorphism. I say I want to pay for my groceries. It could be a electronic check. Could be a debit card payment, it could be a credit card payment, it could be PayPal. I don't care. I just want to pay for something or get paid for something, and it's going to end up in my account. It's going to be outside the control of what happens for me, but it's going to get done in an interesting way that's appropriate to that object. That's a kind of a real-world example. What we saw was the toString, which printed out the details of that object, even though we didn't necessarily know what the type of object was at different points in time. So another way to think about this is you could go through and have a group of people called artists. And they could have a behavior out there which is creating art. Now, we'd all be perfectly willing to say there's different types of artists. When I said artist, you might have been thinking a painter. You might have been thinking a sculptor. You could have been thinking an architect or a singer or a dancer or a football player. You can even say, as a computer programmer, we can be artists, and we will be later on in this class, actually. So this polymorphismic behavior is the idea of creating art. If I ask an artist to create art, they're going to paint. If I ask a sculptor to create art, they're going to sculpt. If I ask, whatever type of artist they are, they're going to create their art in the way they create art. And that's okay. I don't need all artists to be common. If that was the case, I'd have painters, I'd have sculptors, I'd have whatever their specific class is. So the idea is this generalization, specialization we talked about last time comes forward into this is the way I can have that dynamic behavior within that generalized class. I know all artists create art, but I don't care how they create it. I want them to go do it. I'm going to commission them to go do that. They're going to go off and have their different ways of making that happen. And we're going to leverage this behavior inside of our applications. So as I said before, we talked about this within toString. Every object has this method called a toString. If I don't implement toString, I get a default behavior from the object class, which prints out essentially the object's class name and an identifier. So when I implement my toString in the class, I'm changing the behavior for my class of that. I'm now going from being a painter to a sculptor, from a sculptor to a singer, whatever the different way I would want to make those things happen. So we implemented that last week, and now we can attach the word to it, polymorphism. And we're going to expand on this idea. We're going to realize this into our own design this week. But just think in coding how powerful it was. I could just take any object and say, turn this into a string and print it out, and I can see some representation as the human of that object and its data, and I get to choose that representation. That's where polymorphism comes in. I can have a common behavior with different implementations. So, as I said, we didn't implement toString on every object for all time, but the way polymorphism works is I can be guaranteed that some class in that hierarchy has realized that behavior. toString has to be somewhere, because if it wasn't, it would be an abstract behavior. We talked about abstract methods, remember? And there'd be no implementation, and I can't ask nobody to do something. I have to have somebody to do something. And so if, say, in this case, this hierarchy we're looking at here, we have a printed ticket, we have a normal ticket, we have an object ticket. If it's not in printed, then it'll go up to ticket class. If it's not in ticket class, I'm going to go up to object class, and it's going to keep moving forward until I find an implementation. And that's another great thing about polymorphism is once you define a behavior, every class that inherits has that behavior unless they change the behavior. And we'll talk about the mechanics that make that happen as well when we get a little bit further on. But remember the concept. We have this idea of a behavior, and I can change my behavior as part of my class in order to be able to change specifically to what I want to have happen. So in Java, another example we can point to, we'll be looking, it says in a few weeks, it's actually the next class. It'll be looking at collections. And collections is a way to be able to sort and store and or arrange a bunch of data. And so we're going to have certain behaviors that are defined for all collections, but are changed or modified or customized based off of whether it's a list or a set. So a little bit of a preview to something you're going to find out in 252. But there's these behaviors in Java that's part of the core Java language. So we're going to be using this a little bit in design for the stuff we're going to work on, but you're going to see just as many examples of this just in the language as you go off and use different features because it's that powerful, it's that useful. So what we're going to see when we get to collections is we have a common interface. And that's the key part of it. I can add things to a collection. I can clear items from a collection. I can remove items from a collection. And they have some shared behaviors. I can say, hey, is this thing in the collection? Or can I create an array from the collection? But each of them is also going to have unique behaviors that I change the way it happens. We'll learn more, but sets only store one of each item. So if I'm going to play cards, I have 52 cards, and I want to play with a single deck, I only have one ace of spades. I only have one ace of clubs. I only have one queen of hearts. I only have one queen of diamonds. If I try to add more than one, then I just don't add to that deck. I want one of each card. That's what a set does. A list keeps track of the order in which things come in. So I could have 10 decks of cards, and whatever order they have, then that's the way they come out in. Like you have a draw pile or whatnot if you're a card player. So that's kind of the idea behind this. They have common behavior, they have unique behavior. And so there's certain patterns that we're going to use in order to realize designs within polymorphism. The idea is the abstract class is the main class, and I can provide common services to help. So I know this big important thing. I add some services inside of there, but each child determines how that gets used. There's some services in the main class, and then it goes from there. We're going to actually see examples of this here in a second. We'll talk about more in a second, but that's one of the patterns. Is the main class is just kind of some services offered. Now think of it as your cable company. They provide all these channels, but at your house, you choose which one you want to watch. A little bit of analogy there. The other option inside of there is basically this. You have a process to find up high, and you just fill in the holes. Now you can think of this as kind of like a email template or a letter template that you might have when you use Microsoft Word. You say, I want to write a formal letter, and then it'll give you the structure of a formal letter, and you just fill in the holes. Who's it to? Who's it from? What's the body? Things like that. And so that's another use of this. Let's look at it in code here a little bit more. So in one example, we can talk about making a payment. Now, in this example, our abstract class defines the core data we need. To make a payment, we need to know the payment amount, we know the date the payment's going to be made on, and we have this behavior to make a payment. So the core of making a payment is defined up high. Whether I'm a credit card, a PayPal, a electronic check, everybody has to have an amount, a date, and the ability to make a payment. The subclass then, in this case credit card, is the one that really has all the logic. Most of the smarts, most of the guts lives down there. Because that's the guy who has to know, how do I connect to the Visa network, the MasterCard network, the Discover network, the American Express network? How do I make an authorization? How do I complete a transaction? How do I make updates? All those sorts of things is a lot of details that's different for credit cards than for PayPal, which does it a totally different way, which is different than the ACH network, which does it a totally different way. So again, the idea is I have a common way of defining something that is really simple, like a payment. If I'm going to be a website that sells stuff, I just have this idea of a payment, and then I can have each implementation decide how it gets done and choose how it's going to get done. Another way you could look at this is sending an email. Now, most emails are sent the same way, and I can send an email from a common service. You give me the recipients, you give me the the ability to send it. I know how to do that. I know how to send an email. It's the same way no matter what the contents are, but I don't know the contents, so I'm going to ask the subclass to form the subject and the body. So there's many different types of form emails I could hit. One could be a late notice. How many days late is my payment and how much is it due? And so the subclass has to implement what's going to be the title that goes to the subject and what's going to be the body. Hey, you are 10 days late, make a payment now. And the body, your payment of X amount, it was due on this date and now is this number of days late. Please send in your payment right away. So you can see the majority of the code, majority of the logic is up top in the email. I just fill in some stuff down below. These are different examples of polymorphism. Really quick, though, let me tell you something that's not polymorphism. So a stamp, conceptually, is probably not polymorphic. We have to distinguish that polymorphism has unique behavior. What a stamp is I'm going to send the exact same behavior to a different place for a different amount with a different picture on it, but it's going to do the exact same thing every time. I'll see a different result. You can say a Mexican stamp, a Brazilian stamp, a German stamp. I don't know what the other country is there. But fundamentally, all that changes is the amount that goes in the stamp, the picture that goes on the stamp, and the destination. The code to implement a stamp would be the same. The data would be different. All right? So as a student in the class, you all do the same stuff. You have different names, you have different student ID numbers, you get different grades, but you all do the same assignments. I'm not customizing assignments for each of you, so you're not really polymorphic from a teacher's viewpoint. You're just different objects of the same class student, if you will. And I'm not trying to belittle you in any way, but maybe in a way that you can relate a little bit there. Where you'd become polymorphic is when I meet you in the discussion board and I find out that some of you have kids and some of you are young and some of you have been in the military and some of you are maybe not young anymore. Some of you are career changers. Some of you worked on TE. Some of you haven't worked on TE. That's all the different skills you bring to the table and the different ways you'll do your homework. Because if you're older, you might, when we get to some assignments later on, have a lot of fun when I say build a neon sign in the graphics, because you'll say, I know what neon signs are. They were all over when I was a kid. And so you're young, you might be like, I don't know what you mean by this. That's the different things that'll come up. You'll behave differently. You'll get different responses when we get to the creative assignments. So we're going to grow this concept here, but I want to give you a foundation of what is polymorphism, how do we use it. We're going to spend some time playing with using this and doing a little designing next. So I really recommend you dive into that. It's not necessarily going to be something we spend a lot of time for the assignment, but hopefully it'll give you a feel for how this can be used practically.